When we look at an absolute value equation, it's important to remember that x can have two possible values. For example, if x was minus 5, well, absolute value of minus 5 is 5, and the absolute value of 5 is also 5. So there are two possible answers. Here we have the absolute value of x minus 4 equals minus 5. Well, this isn't possible because whatever's inside over here for absolute value must equal a positive number. So this problem can't be done. Here we have the absolute value of x minus 3 equals positive 5. This one can be done. Now there are two possible values that I can put in here for x. So if I had x minus 3 equals minus 5 and x minus 3 equals 5, this accounts for the two possible results that I can have by solving the inside. So if I do it for minus 5, I add 3 to both sides. And I'm going to get x equals minus 2. And for the other one, when I add 3 to both sides, this time the 5 being positive, I have x equals 8. So both of these answers satisfy the equation because if x was minus 2, I would have minus 2 minus 3 inside, and the absolute value of minus 5 is 5. If we were to replace the x by an 8, we then have 8 minus 3, which is 5, and the absolute value of 5 is also 5. So both of these answers satisfy the original absolute value equation. Here we have the absolute value of 3x plus 9, and then to that on the left side I'm subtracting 10, and on the right side the entire thing must equal minus 4. It can be minus 4 because it's not just the absolute value of 3x plus 9 we're talking about. This minus 10 is on the outside. So now in order to be able to solve this, I need to add 10 to both sides. And then this is going to leave the absolute value of 3x plus 9 on its own on the left. So I solve this the same way that I did it before, where I do 3x plus 9 equals 6, and 3x plus 9 equals minus 6. This is to account for the fact that absolute value can have a negative number inside, which would still yield a positive value. Now I simply solve the two equations one at a time. In the case of on the left, I want to get the 3x by itself by subtracting 9 from both sides, leaving me with 3x equals minus 3. I divide both sides by 3, and I get that x is equal to minus 1. Similarly, on the right-hand side, here, I would like to subtract 9 from both sides, which leaves 3x equals minus 15. I divide both sides by 3, and that leaves me with x equals minus 5. Then I test these two values, minus 1 and minus 5, by substituting into the original equation. So first I'll substitute minus 1 for x, which then gives me 3 times minus 1 plus 9, which simplifies to be minus 3 plus 9 inside the absolute value, minus 10 equals minus 4. The next line, absolute value of 6 minus 10 equals minus 4. The absolute value of 6 minus 10 equals minus 4. Now I want to test for minus 5 being substituted up top. So here I've replaced x with minus 5, simplifying for the next line. I have absolute value of minus 15 plus 9, minus 10 equals minus 4. Then the absolute value of minus 6 is 6, and I bring down what I didn't use. And then finally, 6 minus 10 is minus 4, which checks out. This next equation has the absolute value of 2x plus 7 being multiplied by 4. Just like in the last question, I need to get the 2x plus 7 on its own on the left. So the first thing I do is divide both sides by 4, which then gives me the absolute value of 2x plus 7 equals 4. Now it's just a simple matter of setting 2x plus 7 equal to positive and negative 4. In both cases, I'm going to subtract 7 from both sides, and then divide both sides by 2. which gives me the two possible solutions of minus 3/2 and minus 5.5. Now I'm going to test by substituting my two answers in the original equations. So first, I substitute minus 3/2 for x. Simplifying inside, I can simplify the 2's. So I'm left with minus 3 plus 7 inside, which becomes the absolute value of 4. So then 4 times the absolute value of 4 is just 4 times 4. So that answer checks out. Now we'll try minus 5.5. Once I substitute, I can multiply 2 times minus 5.5, which gives me the absolute value of minus 11 plus 7. Further simplifying, I have 4 times the absolute value of minus 4 equals 16. Then finally, that's just going to be 4 times 4, 16. So that again checks out. Stepping up the difficulty, I now have absolute values on both sides here. So in order to solve this, I'm just going to treat one as a positive and one as a negative on this side. So I've rewritten it as 3x minus 4 equals x. So it's positive here, and 3x minus 4 negative x here. So on the left side, I'm going to add 4 to both sides, which gives me 3x equals x plus 4. Then I'll subtract x from both sides to get the x's on one side and the constants on the other. So I have 2x equals 4. Then I divide both sides by 2 to get x equals 2. Looking at the right side, similarly, I'm going to move the x first. So I'm going to add x to both sides, which gives me 4x minus 4 equals 0. Then I add 4 to both sides, which gives me 4x equals 4. Then I divide both sides by 4 and I get x equals 1. Substituting 2 into the original equation, I get absolute value of 6 minus 4, which gives me the absolute value of 2 equals the absolute value of 2. And 2 equals 2 is correct, so that solution is correct. Next, I'll try x equals 1 in the original equation. And simplifying, we get absolute value of 3 minus 4, which is absolute value of minus 1, equals absolute value of 1. And then this further simplifies to be 1 equals 1. So that solution checks out too. In this last example, I want to set the left side equal to a positive and negative right side. So I'm going to rewrite these two as seen here. Working with the left one, I want to distribute and then get the x's on one side and the constants on the other. And then divide both sides by minus 2, giving me x equals minus 6 for the first solution. On the second side, I'm going to do the same by distributing and then moving the x's to one side and the constants to the other. And finally, dividing both sides by 10, giving me x equals 0.8.